Good morning, everyone. It's Ben again from Pragmatic Software Engineering, and today we're going to talk about box types. So I want you to remember how we were talking about booleans, integers, floats, doubles, all those different types of variables in a previous video. We're going to be working with box types, which are a level built upon these fundamentals. Let's go through a thought exercise together. We're going to be building the concept of a person in some code. Let's just say we're doing this because we're trying to build, the concept of a person for telemarketing. So if we're going to start describing a person always has an age. That'll be an integer. A person always has a weight. That'll be a float. We'll keep it in pounds just because I'm in America. And they'll have height in inches, and that will also be a float. Finally, we'll have a phone number for our telemarketers to call. Haha, you thought we were done. We have a slight problem here. Even though it is 2021, not everybody has a phone number. So we're going to have to find a way to denote when somebody doesn't have a phone number. We could use something like 0 or -1, but that's not really a very intuitive solution to programmers here. We could try using null, and actually, let's try it right here. If we go here, and I create a phone number, and I'm going to set it to null, it's not going to work. This is a problem. How are we going to be able to set an integer to be null? Well, we can't do it using this lowercase int way. We're going to use box types to represent this. Up until now, every sort of variable that I've showed you is actually called a primitive. A primitive is almost always lowercase, and it may be shortened. So int, car, float, double, all lowercase. They're all primitives. If we're going to build a box type is in upper camel case. This means that the first letter of every word is capitalized. So if we were to create integer phone number as a box type, we would type integer with a capital I and write it all the way out. And now this is a valid statement. If you want to see some more examples, we could create a character, or we could create a boolean, a float, and a double here. This is not an exhaustive list of all the box types you have, but these are some critical ones you'll need to remember. But not only do box types allow us to set things to null, box types allow us some quality of life features that make our lives as programmers much easier. Let me show you an example. I'm going to turn this into a real number here, and I'm going to say phone number, and I'm going to show you guys everything that this integer box type can do. And some of the things it can do is compare itself to other integers. It also can convert between different types of variables. Here we can convert to a byte or a double, maybe integer, which we already are at, or a long. We can do all these things with box types, and this is why they're very helpful. So box types are different because they can accept null as a value, and they have a lot of quality of life features we can use. One more syntactical thing to understand about box types is that they require initialization before they are used. So if I tried to use this in a way that would not throw a null pointer exception, but I actually want to print out the phone number, this will not work because we need to initialize this box type with a value. I could set it to null, and if we run it, we'll see that I print null. Or I can set it to a real value, and it will also work. But if you try to use a box type without initializing it, Java will complain, and likely your IDE will catch it as well. But if we start working with nulls, what can happen is we can create errors in the code. These errors are called exceptions. Now, we will have an entire episode dedicated to them, but what they can do is cause your code to fail and perhaps actually take your application down. So an example of how a null creates a null pointer exception is we have a phone number that is set to null, and then I ask it for its byte value. What we're doing here is we're asking null for its byte value, and this does not exist. This is an invalid operation in Java. So I'm going to show you what happens when this gets run. As you see here, we've created a null pointer exception on line 8 right here. In conclusion, box types allow us a little bit more flexibility with our code because they accept nulls, and also they're very helpful because they have a lot of functions built into them that make things easier. But if you start to use box types, be careful of null pointer exceptions because they can really screw up your code. Last thing I want to make sure you guys understand, and this is just an extra tidbit of information that I've noticed, when I'm working on things like HackerRank, which is an online sort of interviewing tool, or I'm using CoderPad, a lot of times the Java version that is used in that environment, it works a little bit differently than the OpenJDK. And an example would be if I wanted to create from an integer, let's say, let's create a primitive here. If I wanted to create a box type from a primitive, I could do this easily with this version of Java here. I don't have to do any conversion between them. But in things like HackerRank, you will have to use, this is going to sound crazy, you have to basically create the integer from the primitive, the box type from the primitive. As you can see here, Java is crossing this out, at least in this environment, because it's not needed. But this was something that really screwed me up when I started working on HackerRank things, and I would feel bad if I didn't tell you about this. But anyways, that's all I have for this episode. If you like the video, hit like, subscribe, maybe show it to your friend. If you didn't like the video or you're still confused, feel free to send me a message or leave a comment. Thanks, guys.